Hi, we are back again in the next session. We are in the Electrostatics chapter, and especially in that we are in intensity of electric field. We understood what is an electric field, and the important thing there regarding this electric field is this electric field talks about especially of two charges. Two types of charges. One we will be calling as the source charge, and the other we will be calling as test charge. Already in the earlier class I told you E is exerted by a charge or produced by a charge, and E exerts force on a charge. The same thing exerting a charge, and the same thing I'm mentioning here in this form here. E is of consists of two types of charges. One is the source charge, other one is the test charge. Now, which is the charge which is responsible for this field is called as the source charge, and we'll be calling it as it produces the field. And test charge is just on this the force is produced. That means the force is exerted on this charge. It experiences force. So it experiences force, and we came to know there E is equal to F by Q. This expression we have derived there. And after that we talked about field lines. Field lines are imaginary lines, and we talked about some of the properties regarding these field lines. And after that, now we are going to the another concept. Suppose if you are having two like charges, maybe the positive charges or maybe negative charges, same sign and same magnitude. Now for that here I am going to take plus Q, and another one here, another plus Q. So now just to show the field, how can I show the field? Usually from the positive charge the field lines are produced. That means they originate from here, the positive charge, and they move like this. So one is along this, so they move like this. Okay. Now this charge exerts force on this, and this charge exerts force on this. So the force is exerted on, you can say that the line joining the two charges. So now you can imagine there will be a point on this line joining these two charges where the force by this charge on that charge, and by this charge on that charge, that will be equal in magnitude. That means this exerts force on this, this exerts force on this. So now, and that force will be acting along this line. Now here, because these two are equal in magnitude, certainly we can imagine that somewhere in between here, the two charges, let us name it as F1 and F2. So these two charges will be equal and opposite. So now at this place where the two forces are equal and opposite, there the resultant will be 0. The resultant will be 0. And that point where the resultant or the net force is 0, we will be calling it as the neutral point. And sometimes it is also called as the null point. Okay, so the null point is the point joining the two charges where the force at that point, the resultant net force or resultant force, the net force at that point is equal to 0. Okay. So now, after understanding this, now just you answer a question here. Suppose if I am having the two charges of the same charge, positive charge Q1 and Q2. Let me take here Q1 is greater than Q2. So now usually you can say, or you can make the field lines like this. In the same manner here, the force will be exerted on the line junction the two charges. So certainly on this line there should be a point where the same thing what we have talked earlier, the net resultant force should be 0. So already I said you here Q1 is greater than Q2. This charge is having more magnitude than that charge. So now because of that reason, the neutral point will not lie exactly at the center because the charges are not equal in magnitude. So certainly this exerts more force compared to this charge. So that's why here the neutral point will be nearer to the charge which is having less, which is less in magnitude. That means if you take just as the middle, it will be somewhere here. Nearer, comparatively it is nearer to the charge which is less in magnitude. So here will be your neutral point. Suppose if Q2 is greater than Q1, because this exerts more force, so certainly it will be somewhere here. Okay, nearer to Q1. So like this we'll talk about these neutral points. Okay. Now and after that, one more concept here. Already we talked about the intensity of electric field at a point due to a charge. Suppose if a charge Q is there and I am going to select a point P at a distance R. What is the intensity of electric field at P due to E? Intensity of electric field at P due to E. That means if suppose this charge is producing electric field E, then intensity of electric field is given by E is equal to 1 by 4 pi epsilon naught Q by R square. Okay, and or else if you want to write in the vector form, E is equal to 1 by 4 pi epsilon naught Q by R square in the direction of this radius vector, in the vector form. Here one point is there and one electric field is there due to one charge. Instead of that, if you are having more number of charges, that means if you are having charges Q1, Q2, Q3 and Q4, and this Q1, because of this Q1, one field is produced E1, and because of Q2 another field is produced E2, and because of Q3 another field E3. So likewise we can go for number of fields depending upon the number of charges. Now I am going to select a point P at distance, let this be of R, R1, let the R4, and this is R1, and this is R2, and this is R3. So on P, the intensity of electric field on P due to Q1 is E1. Intensity of electric field on P due to E2 is, due to Q2 is E2. Due to Q3 is E3, and due to Q4 is E4. That means here, individually we can calculate like this. Suppose if there are number of points and number of fields are there, then how can you find the net intensity of electric field on that at that particular point due to various charges? So here, already we know, we came across when you are reading about the Coulomb's law, there we used principle of superposition. In the same manner, here also we are going to apply the principle of superposition. There we talked about an important point while applying the principle of superposition. The force will not be affected by the force of due to a charge is not affected by the force due to the another charge. Similarly, the intensity of electric field due to a field will not be affected by the intensity of due to the another field. The same thing here. There it is the charge and force, here it is the field. So now here, because by applying this principle of superposition here, electric field, the total electric field or net electric field E is equal to E1 plus E2 plus E3 plus dash dash dash. So finding out individually and just going on adding all the intensities. Okay. So now this is how we go with this principle of superposition. So now if the number of points are there, you can apply this, or if a single point is there, if the number of charges are there, you can go with the principle of superposition, and if the single charge is there, we can come like this. So this is about this. Take a slower. Okay, after understanding the concepts, we'll just go with the numerical. It is a simple numerical is there, and a little bit ahead, that means a competitive numerical is there. You can easily solve that if you understand the concept. When I told you, just keep it in mind. If you are good in numericals, certainly you will be perfect in the concepts. Okay, so just keep it in the mind and don't neglect this practice in the numericals. So here this is the simple, very simple numerical based on the just a simple formula. Calculate the electric field intensity. Electric field intensity due to a point charge 20 microcoulomb at a point distance. At a point distance means distance. It is 40 centimeter from the charge. So it's very simple here. So here the charge is there somewhere at some distance R. The point P is there. So you have to find what is E at this place. That's it. So now just applying the formula, E is equal to 1 by 4 pi epsilon naught Q by R square. Okay. Now you know that it is, this value is 9 into 10 to the power of 9. That means we are going to do the problem in SI, and Q is 20 micro means 10 power minus 6 coulomb, no need to mention the symbol there, by R square. It is 40 centimeter. 40 centimeter means it is 0.4 meter. So it is 0.4 whole square. So you can go with the calculation. Our answer will be 1.125 into 10 to the power of 6 Newton per coulomb. You know that the, what do you call it as, the unit of E, intensity of electric field, is Newton per coulomb or volt per meter. Here mention only this Newton per coulomb. Okay, right. So now, so this is a simple problem. I'm coming to the next one. This also will be very simple, just if you understand a very small concept here. The 2 point charges of plus 10 and plus 40 ESU. ESU means electrostatic unit, stat coulomb, it's in CGS, are placed 12 centimeter apart. That means diagrammatically if you go, it is plus 10 or we'll take it as 40 at this side ESU, and the other one is at plus 10 ESU. Okay, now they are separated by the 12 centimeter and the distance between them is 12 centimeter. Okay, now find the position of the point where the intensity is 0. That means we have to find where this neutral point is. We don't know where the neutral point will be because the charges are not equal in magnitude. One is greater, one is bigger one, the other one is the smaller one, smaller in magnitude. So let us think it is somewhere here. We don't know, somewhere. Let this be of distance x from 40 ESU. The point P is at a distance x, unless we assume that we cannot go with the problem. Okay, right. Now, if this is x, how much this will be? It is 12 centimeter. Now, if you are going to do the problem, we have no other way. We have to take 1 by 4 pi epsilon naught, that is 9 into 10 to the power of 9. So certainly we have to go with, let's go with this SA only. So this becomes 0.12 meter. If this is x, and this will be 0.12 minus x. Okay, right. Now at P the intensity is 0. We assume that at P the intensity is 0. The intensity of electric field is 0. First let's find what is the intensity as at P at a distance x. So E of, let me take it as 40. It is 1 by 4 pi epsilon naught Q by R square, isn't it? Q by R square means what I have to do here, it is 40 ESU, isn't it? 40 ESU. So if you just to make it into, I cannot go with the ESU unit, so I will take it as 40 by 3 into 10 to the power of 9 Coulomb. You know that already, you know what you call it as the conversion between ESU and Coulomb. So now, so it is, instead of this ESU, it is 3 into 10 to the power of 9, 40 by 3 into 10 to the power of 9 Coulomb. So it is Q, instead of Q, 40 by 3 into 10 to the power of 9 by R square. What is R square? X square. Okay, so it is 1 by 4 pi epsilon naught. No need to just make it as 9 into the power of 9, you will understand it later. It is 40 by 3 into 10 to the power of 9 into x square. Okay, so let us keep it aside now. Now I am going with 10. So E at 10 is, what is E at 10 now? You are applying the same formula. It is 1 by 4 pi epsilon naught Q. What is Q? It is 10 ESU. If it is 10 ESU, it is 10 by 3 into 10 to the power of 9 Coulomb. So it is 10 by 3 into 10 to the power of 9 divided by, distance is 0.12 minus x whole square. So this becomes 1 by 4 pi epsilon naught 10 by 3 into 10 to the power of 9 into 0.12 minus x whole square. Now this is the electric field intensity due to 40 and the electric field intensity due to 10. So at P their magnitude should be same. So now I can equalize, I can just make this equal. Now here the expression becomes 1 by 4 pi epsilon naught into 40 by 3 into 10 to the power of 9 into x square is equal to 1 by 4 pi epsilon naught into 10 by 3 into 10 to the power of 9 into 0.12 minus x square. 1 by 4 pi epsilon naught, this goes away, 10 ones, 10 fours, 3 into 10 to the power of 9, 3 into 10 to the power of 9. So this becomes 4 by x square is equal to 1 by 0.12 minus x. This is whole square. So here it is 4 x square 1. So that you can making the square root on both sides. So this becomes root of 4 is 2 by x is equal to root of 1 is 1 and square root of 0.12 minus x whole square is 0.12 minus x. So this becomes, just cross multiplying this, it becomes 0.12 into 0.12 into 2, it is 0.24 minus 2x is equal to x. Take this x that side, 3x. So x is equal to 0.24 by 3, it is 0.08. So x is 0.08. That means you should not stop writing the answer here itself. You have to mention from which charge the distance is 0.08 meter. So this is the intensity of electric field is 0 at a distance 0.08 meter from plus 40 ESU. This you have to mention and then you have to stop the problem. Okay. Now just this is very simple. Nothing. We did only one thing here. That is assuming a point where the electric field intensity is 0. Let it be some x. Then we have proceeded the problem using the same E is equal to 1 by 4 pi epsilon naught Q by x square, Q by R square. Okay. and did the very simple calculation. Okay, take a screenshot. After making the screenshot only, then you can enlarge or zoom or whatever you can do. Just by passing, you cannot make it. So just take a screenshot and then let's zoom up further. Okay, now we'll move on to the next concept in this electrostatics, that is electric dipole. From the name itself, you can understand from this dip means two. So here, two types of charges you can see in this. So how to just understand this means? By definition itself, we can understand the two equal and opposite charges. Two equal and opposite charges. Equal, okay, and opposite charges separated by a small vector distance. Separated by a vector distance is called as electric dipole. Now we will be calling this system as electric dipole. How to define this? Two and opposite charges separated by small vector distance is called electric dipole. Okay, right. Now the line joining the two charges, this line, we will be calling it as dipole axis. This is called as dipole axis, and the line passing through this dipole axis, this line, we will be calling it as axial line. And the line passing through the center of dipole axis is bisecting and perpendicular to it, we will be calling this line as equatorial line. Equatorial line. So now electric dipole we understood. We understood about this axial line, the first dipole axis, axial line and equatorial line. Now the strength of this electric dipole we need to find. We need to find the strength of electric dipole, mean that how much effect it is going to show is measured by, it is measured by a quantity called as dipole moment. Measured by dipole moment. So the strength of electric dipole is measured by the dipole moment, and it is denoted by P. What is this dipole moment? So how to get this dipole moment? It's very simple here. Dipole moment is given by, or it is the product of a charge. Among these two, you can select any of the charge because both are same. Product of a charge and their separation. Product of their charge and separation. Yeah. Here we didn't talk about the separation. Here is the case. The two charges are separated by some distance, and here usually we represent the separation by means of R or X or D or L or something else. Here we specify it by 2L or 2X or 2R or 2D or 2P, like something else. Later we will find the use with it. So usually when you are finding something somewhere at some distance, so we will measure always from the center of this dipole. So from the center of this dipole, what is this length? We can be taking it as L. So it will be easier if we just assume it as the 2L. So that is the reason why we are taking it as a 2L. So this is the product of the charge, product of a charge, and the separation gives you the dipole moment. So this is the magnitude, and it is also having the direction. The direction is from this negative charge to the positive charge. So the electric dipole, so this dipole moment is a vector quantity and it is directed from this negative to the positive. So this is a vector quantity, okay, directed along the dipole axis, So this is about this, what you call it as the dipole moment. So let us write the units for this. Q will be in coulomb and 2L will be a length. It's nothing but the meter. So the SI unit of dipole moment is coulomb meter. Okay. Now, after finding this dipole moment and all these things, now there is a need for us to just find out electric intensity of electric field at a point on the axial line and the equatorial line. Okay. So now here it is minus Q and plus Q. So this is electric dipole, and suppose if you are selecting a point on the axial line somewhere here, P. Now it is at a distance R. How to show this R means here, from the center of the dipole axis to the point where we are taking it as the R. And the length of this dipole is 2L, as you already know. So now here the value is given by electric intensity on axial line. It is 1 by 4 pi epsilon naught, and it is 2p by r square minus l square whole square. 2p r. Okay, so using this formula we can find out the electric field intensity on the axial line. So 1 by 4 pi epsilon naught, you know the value, that then it's 10 to the power of 9, and P is given by Q into 2L, and R is the distance from the center of the dipole to the point P. So substituting the value in this, we are going to get it on the axial line. Now coming to the equatorial line. It is 1 by 4 pi epsilon naught, and it is P by R square plus L square whole to the power of 3 by 2. So using this formula we can find out E on equatorial line. E on equatorial line means here, so this is your equatorial line, and you are going to select a point somewhere here which is at distance R. Distance R means from the center of the dipole to the P, it is taken as R. So like that you can find out. So in this intensity of electric field on the axial line, intensity of electric field on the equatorial line, there is a special case. That is, if the distance R, it is very much bigger than this 2L. That means R is very much greater than 2L. Very much greater than 2L means here if this 2L is 2 centimeter and if that R is 200 centimeter, then we can consider it as R is very much bigger than 2L. At that time what we will do is just we will neglect this L square, this L value, and here L value. So what happens here, this becomes 2 pi R square whole square. This is neglected, that means it doesn't exist there. R to the power of 4. So 2p R gets cancelled here, so 2p by R cube. So here we are going to get it as E AX is equal to 1 by 4 pi epsilon naught 2p by R cube. Similarly, if you go for the second one, equatorial line. So if the distance is very much bigger than this one, very much bigger than, that means R is very much greater than 2L. So E equatorial is equal to 1 by 4 pi epsilon naught. So if it is bigger than, we can neglect this value. So P by R square whole to the power of 3 by 2. So it becomes R cube. So it is P by R cube. So like this we can find out we can, in the problems, if you are going to get by looking the values of this dipole axis length and the point of separation, then you can understand easily which formula we can select, and we easily can go with this type of formulas, right? Now, we just want to look into these two formulas here. You can observe one thing here. 1 by 4 pi epsilon naught, these two are same, isn't it? So now, this is 2p and p. R cube are same. Only the difference lies here. This is p and this is 2p. That means, this E on equatorial is, if you just multiply this with 2, we are going to get EAX. That means, EAX is equal to 2 times of EEQ. When we can use this means when this, what you call it as, separation is same. That means on this axial line, on the equatorial line. That means if the distance R value is same, or is same, then you can 2L, R is very much bigger than 2L, and if it is on the axial line of R and equatorial line R is same, you can apply this and you can solve these problems. After just going through this concept, we'll come again with this numericals. You see.